The most dangerous thing in your kitchen may be the glass of water you forgot on the counter overnight. Not because it has become toxic, but because your brain has already decided it feels suspicious. Meanwhile, for most of human history, people drank from rivers, springs, muddy pools, animal tracks, and whatever hollow tree had not yet been claimed by a frog. No filters, no chlorine, no tiny warning label saying may contain civilization-ending diarrhea. So how did ancient humans survive without clean water? The answer is not that their stomachs were magical, their immune systems were indestructible, or everyone quietly replaced water with beer. Ancient people got sick, many died. But they were also skilled observers living in landscapes they understood far better than most of us understand our own plumbing. They learned where water moved, where it settled, when it spoiled, and which sources were worth the risk. Survival began with choosing the least terrible option. Before humans could invent wells, filters, pipes, or the brave decision to drink something bubbling near a dead mammoth, evolution had to solve a more basic problem: how to keep a large, active primate alive in hot, dry landscapes. Water is not optional equipment. It carries nutrients, regulates temperature, lubricates joints, supports digestion, and keeps blood from becoming biologically inconvenient syrup. The human body can survive weeks without food under some conditions, but severe dehydration becomes dangerous within days. That meant our ancestors did not simply wander randomly and hope a lake appeared before lunch. Their movements were tied to water. Part of the solution was already inside the body. Humans are unusually effective sweaters. Sweating helped our ancestors stay active in heat, especially during long-distance walking and persistence hunting, but it came with an expensive subscription fee: constant water loss. The same adaptation that allowed a hunter to keep moving under the midday sun also guaranteed that he would eventually need to find a drink. Evolution gave us excellent cooling and then handed us the bill. Early humans also received water through food. Fruits, roots, leaves, meat, blood, and animal organs all contain moisture. In some environments, food could supply a meaningful share of daily hydration, reducing the need to kneel beside every questionable puddle. But food moisture was a supplement, not a magical replacement for drinking water. A juicy tuber is helpful. It is not a municipal reservoir. The real prerequisite was behavioral intelligence. Humans learned landscapes socially. Older group members could remember which springs survived the dry season, where rain collected in rock depressions, which river bends became stagnant, and how far the next dependable source lay beyond the ridge. This knowledge was not trivia. It was infrastructure stored in human memory. Groups also had to organize their lives around that knowledge. Camps were often placed within practical reach of water, but not necessarily directly on top of it, where insects, predators, floods, and animal waste could turn convenience into a terrible neighborhood choice. People could visit a source, collect what they needed, and retreat to safer ground. So before humans cleaned water, they did something more fundamental. They built a mental map of risk. The first water technology was not a pot, a filter, or a well. It was knowing where to go. Finding water was only half the problem. The other half was deciding whether that water was going to hydrate you or begin a very personal disagreement with your intestines. Ancient humans did not understand bacteria, parasites, or microscopic contamination. Nobody looked into a pond and said, the pathogen count seems elevated. But they could recognize patterns, and natural selection is extremely good at rewarding creatures that notice when certain choices repeatedly end badly. Moving water was often preferable to stagnant water. A spring emerging from rock could be more reliable than a shallow pool warmed by the sun and visited by every thirsty animal in the region. Clear water was not automatically safe, and muddy water was not automatically deadly, but appearance, smell, taste, temperature, and location provided clues. Animal behavior probably helped too. Trails could lead people toward hidden springs or seasonal pools, although following animals was not a perfect quality control system. A gazelle can drink from a place that would send a human digestive system into a week-long spiritual crisis. Still, animals revealed where water existed, especially in dry terrain. Vegetation offered another map. Clusters of moisture-loving plants, greener patches during dry seasons, insects, bird activity, and certain tree species could suggest groundwater or a nearby source. People could also search beneath dry stream beds, digging where water had recently flowed and allowing moisture to seep into a shallow hole. The first attempt might produce something resembling soup. After the sediment settled, however, the upper layer could become more drinkable. Rock cavities and tree hollows collected rain. Dew could be gathered from leaves. Snow and ice could be melted in colder environments. Coastal groups could obtain significant moisture from shellfish and other foods, while desert populations learned the locations of roots, fruits, and plants that stored water underground. None of these methods guaranteed safety. They were ways of improving the odds. And those odds improved through memory. Someone drank from the shaded spring and remained healthy. Someone else drank downstream from a carcass and spent the next 2 days reconsidering every decision that had led them there. Both experiences became information. Humans are exceptional at turning individual suffering into group knowledge. Stories, warnings, habits, and taboos could preserve practical rules long before anyone understood why those rules worked. Do not drink there after heavy rain. Do not camp beside that pool late in the dry season. Let the mud settle. Collect from the upstream side. This was prehistoric water treatment in its earliest form, not sterilizing the source, but reading it, testing it, remembering it, and teaching the next person which mistakes were unnecessary. Eventually, humans stopped treating water as something they had to chase and began forcing the landscape to provide it on demand. That shift appears clearly in the archaeological record with wells. Some of the most remarkable examples come from early Neolithic farming communities in Central Europe. Wooden wells discovered in what is now Germany have been dated to roughly 5069 to 5098 BC. These were not crude pits scraped into the ground by people hoping for the best. Their builders shaped oak timbers with stone tools, joined them into carefully fitted structures, and lowered them into the earth to reach groundwater. This matters because a well changes the entire survival equation. Surface water is exposed, animals drink from it. Waste washes into it, sunlight warms it. Seasonal drought can shrink it into a concentrated puddle of mud, insects, and regret. Groundwater, by contrast, has often passed through layers of soil, sand, and rock that remove some suspended material and reduce certain forms of contamination. Not all groundwater is safe, of course. A crystal clear well can still contain pathogens, minerals, or chemical contaminants. Archaeology does not support the comforting idea that ancient wells produced perfect bottled water with a rustic label. But compared with an open pool beside a settlement, a protected well could offer a more stable and controllable source. Building one required far more than thirst. People had to understand where groundwater might be found, organize labor, remove large amounts of soil, prevent the shaft from collapsing, shape wood precisely, and maintain the structure after construction. In other words, the earliest wells were not merely holes. They were community projects. They also reveal how settled life intensified the water problem. Mobile hunter-gatherers could leave when a source failed or became contaminated. Farmers had fields, stored grain, houses, livestock, and neighbors who had apparently decided to remain nearby forever. Once people invested in permanent settlements, moving every time the local stream became unpleasant was no longer an attractive business model. Reliable water therefore became part of architecture. It determined where villages could grow, how long people could remain in one place, and how many humans and animals an area could support. The archaeological evidence does not tell us the name of the first person who suggested digging downward instead of walking farther, but it preserves the result: timber walls buried in ancient soil, built by people who had transformed water from a lucky discovery into planned infrastructure. The puddle had become a public utility. Here is where the story becomes frustrating, because the most interesting question is also the hardest one to prove. Did prehistoric humans deliberately treat water before drinking it? They certainly possessed some of the necessary technology. Humans controlled fire long before the invention of pottery, and later communities heated liquids in ceramic vessels or by dropping fire-heated stones into containers, pits, baskets, or hide-lined hollows. Experiments show that hot stones can bring water to a boil, but proving that people boiled water specifically to kill invisible pathogens is another matter. Boiling leaves very little archaeological evidence. A hearth proves that someone made a fire. A cracked stone may show repeated heating and cooling. A pot can preserve traces of cooked food. None of these objects comes with a label reading "emergency drinking water," prepared because the stream looked medically adventurous. People probably heated water for cooking, softening food, extracting fat, processing plants, preparing medicines, or making broths. Any reduction in disease may initially have been a useful side effect rather than the intended goal. They did not need germ theory to notice that some practices produced fewer unpleasant consequences, but archaeology rarely preserves the observation itself. The same problem applies to straining water through cloth, sand, grass, bark, or charcoal. These materials can remove insects, mud, and suspended particles. Settling water in a container can also make it clearer. Yet clearer does not necessarily mean microbiologically safe. A homemade filter may improve texture while leaving the truly ambitious organisms untouched. Then there is the popular claim that ancient humans survived dirty water because they had stronger immune systems. They may have developed partial immunity to certain local pathogens after repeated exposure. Gut microbiomes and childhood exposure also differed from ours. But this was not biological armor. Contaminated water still caused diarrhea, parasites, dehydration, and death, especially among children. Ancient cemeteries are not evidence of a wellness trend. And no, people did not universally solve the problem by drinking beer instead of water. Fermentation and heating during brewing could reduce some risks in certain settings, but beer required grain, labor, containers, and usually water in the first place. A mobile Paleolithic group was not carrying a refrigerated keg across the savannah. The honest conclusion is less dramatic and more interesting. Ancient people probably used many water-improving techniques in different places and periods, but the evidence is uneven. Some methods are technologically plausible. Some are historically documented much later. Some are modern survival advice projected backward. Prehistory rarely gives us a confession. It gives us clues. Once water became dependable, it stopped being merely something people drank and became something societies organized themselves around. A permanent well could turn a campsite into a village. A reservoir could carry a community through the dry season. Channels could move water toward fields, animals, workshops, baths, kitchens, and places of worship. The moment humans began controlling water at scale, hydration became politics. Someone had to dig. Someone had to maintain the walls. Someone had to decide who drank first when the level dropped. And someone, inevitably, stood nearby explaining that the water shortage was caused by the previous administration. Across the ancient world, communities developed different solutions. People built cisterns to collect rainwater, cut channels into stone, lined storage pits to reduce leakage, and transported water in ceramic vessels. In cities, fountains and wells became social centers where people exchanged news, negotiated marriages, argued about neighbors, and performed the timeless ritual of waiting behind someone who had brought far too many containers. Water also acquired sacred meaning. Springs, rivers, and wells were often treated as places connected to gods, healing, fertility, or purification. This was not simply superstition floating above practical life. A protected sacred spring might also be a carefully maintained communal resource. Ritual rules could control who approached it, when it was used, and what kinds of contamination were forbidden nearby. Religion sometimes functioned as environmental management with better storytelling. Medicine became involved too. Ancient physicians did not know about microbes, but some recognized that water quality varied by source, season, taste, smell, and location. Water could be allowed to settle, strained through fabric, exposed to heat, or mixed with other substances. The cloth strainer, later associated with the medical tradition of Hippocrates, was intended to remove visible impurities from boiled water. It was not a modern purifier, but it reflected an important change. People were no longer just choosing water. They were evaluating and modifying it. Large states pushed this transformation further. Aqueducts, pipelines, drainage systems, public fountains, baths, and sewers required surveying, engineering, taxation, labor, and administration. These systems did not eliminate waterborne disease. Roman water networks, for example, were impressive but still vulnerable to contamination. Poor maintenance and unequal access. Yet the broader achievement was extraordinary. Human communities had converted scattered knowledge about springs, mud, rainfall, and groundwater into shared infrastructure. Clean water was never simply discovered. It was negotiated, engineered, ritualized, and defended. Today, clean water arrives so quietly that most of us only notice it when it stops. You turn a handle, and centuries of engineering appear in a glass. Protected reservoirs, treatment plants, pumps, pipes, chemical testing, filtration, and entire professions devoted to preventing your breakfast from becoming an epidemiological event. It feels automatic because civilization has hidden the effort. Ancient humans had no such illusion. They understood water as a relationship with a landscape. A spring could weaken, a pool could spoil. A river could flood, shift, or carry waste from somewhere upstream. Survival depended on attention, remembering seasons, recognizing plants, following animal paths, tasting cautiously, digging patiently and listening when an older person said, "Not that one." This does not mean they were healthier, stronger, or somehow naturally compatible with parasites. Many people became sick. Many children died from infections and dehydration. The success of our ancestors was not that dirty water failed to harm them. It was that enough people learned. They turned experience into warnings, warnings into customs, customs into technology, and technology into institutions. A shallow hole became a lined well. A storage pit became a cistern. A channel became an aqueduct. A shared rule about protecting a spring eventually became sanitation law, public health, and the modern expectation that a glass of water should not contain anything with its own reproductive strategy. That history also explains why access to safe water remains one of civilization's clearest dividing lines. The difference between security and disaster is often not whether water exists, but whether communities can protect, transport, test, and share it reliably. So how did ancient humans survive without clean water? They often did not have perfectly clean water. They had judgment, mobility, cooperation, accumulated knowledge, and an improving ability to make dangerous sources less dangerous. And every time you reject a glass because it has been sitting out for 6 hours, remember that your ancestors once evaluated drinking water by checking whether the frog inside looked healthy. We inherited their caution. We simply outsourced the puddle.